Welcome to this episode of Ask STARBASE. I'm Dory, here to answer a question from Mr. Stark from IMS. Mr. Stark would like to know, how do aerodynamics work? How do they apply to planes and other flying vehicles? Aerodynamics is all about how things move through the air. It belongs to a branch of physics called fluid dynamics, or the study of moving liquids and gases. Aerodynamics focuses on the forces present in air and the resulting motion of objects as they travel through the air. The big idea being to create designs that allow objects to travel through the air more easily, leading to faster speeds, shorter travel times, and more efficient use of fuels. People working in this field learn about how gases and liquids flow, what causes drag or friction with liquids and gases, how the volume and energy in a fluid stays the same as it flows, and the mathematical equations we can use to model these concepts. Scientists and engineers can use technology like wind tunnels to see how well air will flow around different designs, often using small-scale prototypes or test models to plan for larger vehicles. The information collected from wind tunnel testing has led to all kinds of advancements, ranging from spoilers for drag racers to wings for supersonic military aircraft. So how does this relate to planes and other aircraft? Vehicles that fly through the air are subject to 4 different forces: weight, lift, thrust, and drag. Gravity causes the aircraft to have weight, pulling the vehicle closer to the Earth. Lift is the upward force that acts in the opposite direction of gravity. Thrust is provided by an aircraft's engines, pushing the vehicle forward by forcing gases out the back. Drag pushes in the opposite direction. This force comes from contact between the air and the surfaces that make up the front of the aircraft. If you've ever put your hand outside the window of a moving car, you have experienced drag. The higher the speed, the greater the amount of drag an object experiences. When these forces are properly balanced, an aircraft can be lifted off the ground, fly level to the ground, or land safely on a runway. Pilots learn how to use different controls to adjust flaps along the wings and provide the necessary thrust to generate enough lift to take off and control the motion of a plane. While most of these forces have relatively simple explanations, the theories behind lift have varied greatly. All of these ideas center on how the air moves over the wings of a plane, also known as airfoils. While some people or books will reference something known as Bernoulli's principle, it turns out that this force is generated by a combination of pressure differences and Newton's third law of motion. Air flowing over the wing is accelerated up over the top surface, then pushed downward. According to Newton's third law, for every action, there is an equal and opposite reaction, so this downward force generates an upward one of the same size. The air below the wing has a higher pressure than the air above the wing, causing it to move upwards, generating lift. But if we need wings to have lift, how do helicopters work? It turns out they do have parts that act like airfoils. They're rotor blades. Unlike an airplane, helicopters don't have to travel down a runway to reach the necessary speed for takeoff. These machines spin their rotor blades through the air, pushing air down to generate the same pressure imbalance we see with fixed-wing aircraft. The pilots speed up the main rotor and set the blades to the proper angle to generate enough lift for takeoff. While the generation of lift is similar, helicopters require an additional rotor to prevent them from spinning in place by the main rotor pushing the air to one side. Many designs use tail rotors to counteract this force. In other cases, designs may include coaxial or tandem rotors. Coaxial rotors are mounted in the same place as the main rotor, while tandem rotors are located on the opposite ends of a helicopter. In both of these designs, the rotor spins in the opposite direction to the main rotor to keep the aircraft balanced. Thank you for watching this episode of Ask STARBASE, and a special thank you to Mr. Stark for asking these questions. If you have a STEM question you would like answered, please email it to us at ask@starbase-ct.com or go to our website at www.starbase-ct.com and go to the Flipgrid at the bottom to submit your question. Stay safe and be well. Goodbye.